Today I am going to teach you about total internal reflection. The concepts and basics of this total internal reflection I have already completed in the previous class. Okay. Now today I just want to focus on total internal reflection in two glass prisms. The ones which are very important for you and in your syllabus. Now the first glass prism that you have is the right-angled isosceles prism, and the second glass prism is your equilateral prism. Okay? Now, just remember that the critical angle for the glass air interface is 42 degrees for a glass prism, right? Now, here as you can see, most of the time I know there's a tendency to just memorize the diagrams and go for exam. Please don't do that, yeah? I'm going to make it simplified and easy so you can literally solve it for yourselves and enjoy it as well. Okay? Now for example, let's take the first one, the right-angled isosceles prism. The ray should always be chosen in such a way that it should pass undeviated through the first surface. That means it is along the normal. Right? Good. Now, so we have taken a ray which passes undeviated here through the first surface. But when it goes to the second surface, you can see that it is deviating here at 90. In other words, the angle of incidence is 45. How did this come about? No, you need to ask, how did it become 45? Simple reason, just the concepts of triangles. Yes. Now, let us assume, take this triangle. Here you know that the vertex angle is 45 degrees. This is 90 because it was at the normal. So obviously this angle should also be 45. Clear? Now, if this is 45, I have drawn something here. This is nothing but a normal to which face? This second face. It's a normal. So if it's a normal, so this entire angle here should be 90 degrees. Okay. So if this is 45, obviously this is also 45. So there. So you have your angle of incidence. Now, according to laws of reflection, angle of incidence should always be equal to angle of reflection. So this is 45, this is also 45, and hence it suffers total internal reflection. Why? Because this angle or the angle of incidence is greater than the critical angle, which is 42 degrees. And hence it comes out here. And then you can see that it goes along the normal and out. Next big question, how do I know it goes along the normal? These are the type of questions you would ask, right? How do I know? Again, back to your triangles. This is 45. Now here once again, it's 90. If this is 45, this is also 45 degrees. So you have your 45 and 45. There you go. This is 90. So hence it's traveling along the normal and hence it goes out of the prism. So this is the way you deviate an angle through 90 degrees. Total here, see? 90 degrees. And this is used in a periscope. Sophisticated periscopes. We don't use mirrors in them, but we use prism. Okay. Now let's go to the next topic, the equilateral prism. The same funda works here. Like for example, the first ray is taken, which is along the normal. You can see here, goes along the normal, right here, and here it bends. See, can you see here? 60 is angle of incidence, 60 is angle of reflection. Why 60? Once again, come back to your triangles. Take this triangle here. This is 60 and this is 90 because it's along the normal. So obviously this should be 30 degrees. Done. Now if that is 30, you must have noticed I've drawn here the perpendicular to this, which is a normal. Yes. Now if this is a normal, this is 30, this is 60. So the angle of incidence is, what is an angle of incidence? The angle between the incident ray and the normal. So here we go. You have 60 degrees. And according to laws of reflection, angle of incidence is always equal to angle of reflection. So you have 60 again. And now, since the angle of incidence is 60, which is greater than the critical angle 42, hence it suffers total internal reflection. So you can see here very clearly, comes right out. Once again, it is showing that it's going through 90. How is it 90? Simple. Just take the triangular property here. If this is 60, this is is 30 here, right? So this is 30 and 60, this is 90. So then this is an awesome proof that you have. So there are many more tips and tricks for other triangles which I can teach you, but we'll be doing it in the later classes. So I hope you enjoyed the class. Thank you.